E, F, G. What? I'm in love with. I don't know. Okay.
Finding P.
Finding P. That's not right. That doesn't sound right. Alright. So, we gotta find P, which is the end center. The thing to know about the end center is it's always inside. That means that the circle is inside. It creates that circle that's inside. Okay? If we're going to find that circle that's inside, we're going to use what's called the angle bisector. Okay? So, how do you find P?
8. I was on the phone for like 12 in the morning. I was like, gotta go. Bye. And then I woke up at 6.
Which is the angle bisector theorem. And the angle bisector theorem says this. If I bisect each angle, they intersect at P, which is the end center. So I just cut this in half. Whoop. Cut this in half.
Cut it.
Whoop.
Cut it.
No, that's not quite in half. Whoop. There we go. Look at that. There's P. Look at that. Okay? Now, remember, there is a circle created in here, right? A circle is created in here. And that circle has these radii that are perpendicular. And those radii are where X, Y, and Z are. Okay? So we just moved them a little bit. That's where X, Y, and Z are. Is those now they're not bisectors. These are just perpendiculars. And these are all radii, so these are all the same length. So that means that the length of XP and the length of YP and the length of ZP are all the same. So XP is equal to YP is equal to ZP, which is the definition of an end center. Okay?
Is that number 2?
Yeah. Okay? Now, the other thing is all these angles are congruent. The definition of the angle bisector right? Which came from the end center, means that they're all congruent. All of these angles. So, angle PAZ is congruent to angle PAC, right? So these are congruent. Angle PCA is congruent to angle PCB. Right? That means these are congruent. And angle PBC is congruent to angle PBZ or A. Whatever you want to. Okay? Now those are all congruent. Not to each other, but these two are congruent, these two are congruent, these two are congruent, right? And that's huge. Because now we're given this. Given. And because this is given to us, right? How do we find BCA? BCA would be these two, right? Well, we're given that XCP is 26. That means this is 26, right?
2.
Okay? So if XCP is 26, so get this. If XCP, PCA, so PCA is 26, right? So if this is 26, then this is 26. Does that make sense? Okay? That means PCB equals 26. Okay? Substitution. And definition of congruency. Okay? So these are 26. So if they're both 26, ACB is equal to PCB plus PCA, so 26 plus 26, right? Okay. So what's this one? Well, this is angle addition postulate, right? Two angles add up to be a third angle. And then substitution. Right? And then simplification. So ACB is equal to 52. Okay. So equals 52. All right. That was easy. Right? So these add up to be 52 degrees. What else does it say? It says BAC is equal to 10, right? That's given. If that's given, what do we know from before? We know this. PAB. Which one's PAB? PBA, no. PAB. This one, right? PAC and PAC. Oh, I did Z instead of B. That's all. Okay? So PAB, we know that these two add up to be 10, right? We know that PAB plus PAC is equal to what? Angle A, right?
5.
Or BAC, which is this, 10. So we plug that in, and we know that those are equal, right? So basically 2x equals 10 if we let those be x, right? So that is angle addition postulate. And this is substituting x in there, right? Substituting the 10. Okay? So this is 8, 9, 10, right? And then what do we do to solve for x?